Now we'll look at a couple of examples of using the chain rule in conjunction with some of our other rules. In this case, when I see what I'm looking at here is I see an outside function blank to the 10th power. So the power function x to the 10th is the outside function. And then I see an inside function that involves a quotient rule. So involves a quotient, which means I'm going to have to use the quotient rule somewhere in this process. So I start on the outside. If I want to find y prime, starting on the outside, just ignore all of the inside function. The outside function has a derivative of 10 blank to the 9th. But because there's something in there other than just x, I have to put the inside function inside of my derivative and then multiply by the derivative of that inside function. So now my task is to do the derivative of this quotient that I have here. So it's going to be 10x minus 2 over 2x plus 1. That's all to the 9th. Okay, so this is going to be the derivative of the top times the bottom minus the derivative of the bottom times the top. And then that's all divided by the bottom squared. So now I've reduced it down to just finding the derivatives of these two, which are very straightforward. So I've got this 10x minus 2, 2x plus 1 to the 9. This is going to just be 1 times 2x plus 1 minus this derivative is just going to be 2 times x plus 1. X minus 2, can't read that, didn't come out real well. It's x minus 2. All right, and then that's all divided by 2x plus 1 squared. So continuing, I'm going to go ahead and do this numerator without rewriting everything. So this numerator turns into 2x plus 1 minus, when I distribute the 2 and the negative, it's going to be minus 2x plus 4. So that numerator is going to, the 2x's are going to cancel out. 1 plus 4, it looks like I'm just going to get a 5 in that numerator. So I have 10. And I'm going to go ahead and break this up now as x minus 2 to the 9th. And this is 2x plus 1 to the 9th. We can use the rules of exponents to do that. And then, like I said, this is just 5 over 2x plus 1 squared. So I'm going to move my factors around, collect things together. So for example, the 5 and the 10 multiplied together, that's 50. I've got my x minus 2 to the 9th. And then down here in the bottom, these two can be combined by adding those exponents, and I'll have 2x plus 1 to the 11th. So that would be my derivative of that composition of functions that we have there. So you just do the product rule when you get to it. I could have rewritten this right at the start as x minus 2 to the 10th over 2x plus 1 to the 10th. Had I done that, then the first thing I would do is I would start with the quotient rule, because when I look at this, I see a quotient first. But then in that quotient rule, it would require some power chain rules. But that's what this next example is going to address. So you can always manipulate them before you start if it's more convenient, or you prefer to do a derivative in a different way. So let's look at this one. I can't really manipulate it. I definitely don't want to multiply all this out. That would be a big mistake. Multiplying this out 5 times itself, this 4 times itself, and then the result times itself. It would be a horrible thing to try to take derivative of. But from what I'm looking at, it's a product. So if I want to take the derivative, the first thing I see is a product. So it's the derivative of the first, which is 2x plus 1 to the 5th plus 1 to the 5th times the second. I'm getting too many. Let's try again. Times the second, which is x squared minus x plus 1 to the 4th, plus the derivative of the second one. What's the derivative of x squared minus x plus 1 to the 4th times the first, 2x plus 1 to the 5th. So I got to take derivative of that, of these two things. Well, each of these now require the chain rule. They have an inside and outside function. So this first one, Start on the outside, I got 5 blank to the 4th. Now put the inside function back in, and then multiply by the derivative of the inside function. I think I can do that all in one step. So put the inside function in, derivative 2x plus 1 is 2. And then this was here from the product rule. Next, taking the derivative here, again, it's going to be a chain rule. I'm going to take the outside function is blank to the 4th, so it's going to be 4 blank to the 3rd. Put the inside function back in, x squared minus x plus 1, and then multiply by the derivative of the inside function. Again, I think I can do that without having to rewrite it. The derivative of the inside function is 2x minus 1. And then this 2x plus 1 to the 5th was there from the product rule that we originally applied. And so now it's a matter of trying to clean this mess up that I have here. But the best way to try to deal with simplifying what I've got here is not to multiply things out. You always try to factor before you do anything else. And there are things that will factor here. For example, I can see this 2x plus 1 and 2x plus 1. There's only 2 terms here, right? There's this first term from our quotient rule and then the second term. So each of those terms has a 2x plus 1. Well, they've only got 4. That's the best I can do, is I can take 4 of those out. That'll still leave 1 over here. This 2 is common to both of them, so I'm going to go ahead and put it in the front. I'm going to take that 2 out. Some of that will come out. Not all of it. And then the next thing I can see is there's an x squared minus x plus 1. X squared minus x plus 1. Well, there's 3 of them here, 4 of them here, so the best I can do is take 3 of those out. And then let's look at what's left. This 5 is still there. I took out all 4 of these, and I took out this, but one of these has to remain because I only was able to take out 3 of those. So that's what I have left in the first term. Plus, in the second term, I took out 2, so factored out of 2, there's still a 2 there. This 2x minus 1, I couldn't do anything with that. And then this 2x plus 5, I took out 4 of those. 2x plus 1 to the 4th. So there's still one of these here. And so now we'll see what all of this turns into. Well, without rewriting everything again, let's just work with this. This part, let's start here. I'm going to have 2 times. Using FOIL, I'm going to have 2x times 2x. That's 4x squared. And, well, this is the difference of squares, right? So it's 4x squared minus 1. Because it's a minus b times a plus b. The middle term is going to cancel. And this one is 5 times x squared minus x plus 1, and then that's going to be added. So here's what I'm going to be adding. 5x squared minus 5x plus 5. I'm going to be adding that to 8x squared minus 2, and that will all combine to give me 13x squared minus 5x and plus 3. So what I end up with, once I do my simplifying there, go a little farther down, I end up with 2 times 2x plus 1 to the 4th times x squared minus x plus 1 to the 3rd times this thing, 13x squared minus 5x plus 3. And if this factors, you should factor it. And when you're doing derivatives, you try to get things simplified as far as you can by factoring, canceling, all of that stuff. You can try trial and error. That 13 and 3, there's no way for you to get that 5 in the middle through trial and error. So this is the derivative of that function right there. But notice it's a very complicated function. Took quite a bit of work. We get a very complicated derivative, but not too bad. I mean, we just use basic algebra all the way through here. But that's what I said. Chain rule allows us to take derivatives of some fairly complicated looking functions, especially when we start combining them with all our other operations and our other rules.